Hi, I'm Jason Mears and this is Public Cloud for VMware Users 103, Workloads. So in a previous video we looked at compute and services, and this time I'd like to go into a little bit more detail about them. We're going to talk about virtual machines, containers, something you might have heard around Docker and Kubernetes, the current buzzwords around those, functions, something you might have heard as serverless, Lambda or Cloud Run. There's also another thing here called App Engine or an app service or something like Elastic Beanstalk. We're not going to cover those in this video. That's an entirely different topic. So I just want to call out that they do exist, but just for the purposes of this video, we're just going to cover VMs, containers, and functions. So if I start with the anatomy of an application, for most people that starts with an operating system, which will be Windows or Linux. On top of that, we'll put any application dependencies, anything like .NET Framework, Java, maybe even parts of a web server or any other libraries. But there's essentially a set of code or dependencies that need to be on top of the operating system in order for the application above to be able to work. So just like you may want to travel from one place to another, and you want to get in your car and go from one city to another, a dependency might be that you have a driving license and you have insurance and you have fuel, either petrol or diesel or electric. But I guess what we're saying is the application dependency is the bit in the middle. It's not actually what you want to achieve, it's just the supporting stuff you need in order to be able to do it. So typical app looks like operating system, dependencies, and then the application itself. So if I was to take an application like that and I was to build 3 different ones of them, so I've now got 3 different applications. What I could do if I wanted to was to take all of that stack, that operating system, dependencies and application, and I could squash that all down into a VM or virtual machine, and that's how I could run virtual machines on top of a hypervisor, and each of those virtual machines would contain the application, any application dependencies and an operating system. So for 3 apps I'd create 3 virtual machines. That's the way that we've been doing things for probably the last 20 years or so. And in order to run those virtual machines, I need the bare minimum is a server running a hypervisor. So that's how I run 3 applications in 3 VMs on a server with a hypervisor. The next thing after that is I could take those same 3 VMs, but what I could do, I could add a very thin or optimized version of Linux. I could then run a container runtime on top of that, the most popular one or the most well-known one being Docker. So I now have a very slim operating system containing a container runtime. What I can do now, because I've got that operating system and container runtime, is I could get rid of the operating system from the application, from each application, and now I just package up the dependencies in the application on their own or individually into a container, and that container runs on that operating system at the bottom, the purple strip. Now I do the same thing for the other 2 applications. What you'll notice is I still have 3 applications, they're now in 3 containers, but there's only one operating system at the bottom. So I've decoupled the operating system from the application, and that's done using a container runtime, as I said, the most popular one being one called Docker. So all I need really to run containers is a container runtime of some sort. If we go back to the application, and we just go into a bit more detail, so we've got the operating system, the dependencies, and the application. If we were to look a little bit deeper into that application, we would probably find that inside there's individual pieces of code that perform specific functions. So for example, there might be a piece of code or a function that loads records into the application, one that processes or manipulates the records, ones that saves the modified records, maybe another one that creates a report from the modified records, and then another one which possibly emails off the report to somewhere else. So I've got several different functions inside of a single application. There might be other things inside the application which perform something we call batch jobs. So it might be that there's a special job that runs at the end of the month, or there might be a special job that runs on a regular basis to do stock control and reordering. But either way, what we're saying there is that there is there's more detail inside the application itself, and those smaller pieces of code that do specific things are called functions. So what we could do then is strip out the operating system, strip out the dependencies, and actually just get left with the functions themselves. So none of these functions do much on their own, but when you combine them together, they make up the whole application. So one of the things I could do would be to take just the code in that function and package it up as just a standalone function. And I could do that for all the code that does specific jobs. So I now have a number of different functions which can all work independently, and they would be run as and when required. I could take this batch job, and what I could do then is bundle that up again, but this can be run whenever is convenient or whenever the cost is suitable. So we talked about spot pricing and spot instances before. It might be that I don't care when this job is done, but I would like it done as cost effectively or cheaply as possible. So I might put this job on a spot instance and say, when it's cheapest to run this, so that if I'm not bothered too much when it runs, I just care that I pay as little as possible. I could maybe do this as a spot instance or a spot kind of payment. So that's functions, and the bare minimum to be able to run a function is a platform that supports functions. Now, because the end user never sees the servers behind this, there is a trend in the industry, or a common parlance in the industry, to call this serverless. These functions do actually run on a server, they have to. It's just that the user doesn't see the server or is not aware of the server. So it's not the best named technology in the IT industry, but that's what we're stuck with. It's called serverless, even though it uses servers. It's just that the user cannot see them or is not aware of them. So let's just do a bit of a summary on that again, the things we've just learned. So a VM runs on a server running a hypervisor. So that's the bare minimum for running a VM. A container runs on a container runtime, and a function runs on a serverless environment. So just to wrap that up again, what is a VM? It's a virtual machine. It consists of the application, any dependencies, and the operating system. And it runs on a server with a hypervisor. So what is a container? It's an application that's been packaged up for a container runtime such as Docker. And it consists of the application, any dependencies, but importantly, it does not contain the operating system. And that runs on a container runtime. The next one, what is a function? It's a small piece of computer code that can perform one particular task independently, and the whole point of this is it only consists of just enough code to perform the task. And a function runs on some form of serverless environment. So that's the end of that particular video. Next time we're going to talk more about, in video 104, computing resources and services. We're going to talk about the specific public cloud offerings from the 3 largest public cloud providers. So we're going to talk about specific services and offerings from Amazon, Google, Microsoft, and a little sneak peek at VMware's Cloud Foundation, which we'll cover in a subsequent video after 104, computing resources and services, the public cloud offerings. So thank you very much for your time, and I hope you found that useful.